morning, everyone. Thank you for coming here for this presentation. My name is Álvaro Sánchez, and I promise you two things. You will learn something new, and you will have fun. So let's try. Little bit about myself. I'm coming from Leganés, Madrid. I support Leganés Football Club, also Real Madrid, so probably few of you were happy about the last night result. I'm a Java developer. I've been always working with Java, and at the moment I'm working on Micronaut at Oracle, different parts of the framework. I'm a member of the part of Oracle that I'm working for is called Oracle Labs. It's a research and development organization, and is also the home of a GraalVM. I'm not a developer advocate myself. I'm just a committer on the project. But I enjoy going to conferences like this one to talk about Java, Micronaut, etc. And I'm really proud that I've never, ever done any single talk about AI. But believe me, it's increasingly difficult to get into conferences without talking about AI. At a personal level, let me tell you that I'm a runner. Yes, don't be surprised. I'm a runner. I run a lot. I run applications and run containers, and I run them very fast, very fast. So I've been working on Micronaut. But let me tell you a story which is a true story. So Micronaut originally wasn't named Micronaut. The code name of the project was Particle, because we wanted to find like a name which was like really tiny. So Particle was like great, but we couldn't choose the name because I don't know, there was a trademark of a different product. The domain name was not available, whatever. So we had to run a poll across the team to choose a new name. And my proposal was to name, this is true, it's funny but true at the same time. My proposal was to name the framework Summer, because we all know that summer is better than spring. OK, enough about me. So I have slides in speaker deck, and not only this one, but also a few others. And in the meantime, let me ask you a few questions about you. So how many of you are using Spring Boot? Please raise your hands. Thank you very much. Exit is over there. No, you're in the right place. Is anyone using Quarkus here? We have one Quarkus committer. Are you a Quarkus committer? Yes? OK. I'll try to be polite. No, it's OK. Is anyone using Micronaut here? Well, we have a few users. That's great. Anyone using anything else, like, I don't know, Helidon, Jakarta EE, or No Framework? Yeah. OK. Fair enough. So I'm here not to talk about frameworks, or not directly about frameworks, but about annotations. So we all use annotations, because all the frameworks in Java are based on annotations. But the question is, how do they work? How can you make it? For example, when you have a transactional in a method, what's happening under the covers? And the answer to this question is that there are different techniques in Java, in general, that can be used to make this work. And there are some frameworks using one strategy, other frameworks use other, and I will try to explain you all the possibilities. So essentially, annotation processing in Java is a two-step process, right? You need to, first of all, you need to discover the annotated elements, right? We need to have a way to find this add transactional in a method. And once you found it, you need to implement the logic. So for example, for the add transactional, the logic is quite simple, right? You need to intercept the method call. You need to start the transaction before the method call, then delegate to the real method, and then after the method has finished, then you basically commit or roll back the transaction based on the result of the method. But how do you implement that is the question. So I will begin with runtime annotation processing, which is like the most used because it is what Spring is using, and Spring is the most popular framework. So let's talk about that. When you have a Spring application, Spring will use a technique called class path scanning. And class path scanning means we're talking here, first of all, how to discover, like first part, no? Class path scanning means that Spring will iterate over all the classes of your application, your jar files, right? To find annotated elements. Throughout this presentation, by the way, I've included like these warning icons to highlight things which I think they are not optimal or could be done differently, right? And I will explain later why. So they will iterate over the classes of a custom package or a given package. And using a custom class loader, they will load the classes into the class loader. Because without loading the class, you're not able to see anything about them, right? Loading a class has a cost of actually initializing the class. So all the static initializers of the class will be run at the moment, right? Because you're loading the class. Then once the class is loaded into this custom class loader, they will use the reflection API to query. Like, for example, if I'm loading a class, I need to tell the reflection API, OK, give me, first of all, the annotations on the type, on the class. And then, using another reflection call, I will ask, give me all the methods of this class. And for each of them, give me all the annotations of these methods, so on and so forth, right? And this will happen every time you run your application, every time. And this happens not only on classes, but also on fields and methods, right? So it is an extensive operation. So the ones using Spring, is any of you using Spring AOT already? Yes, this is, I'm asking this question frequently, and it's still surprising that there's few people using Spring AOT. Because as far as I can tell, I think Spring AOT is the future where they want to go with the framework, because Spring AOT will save some of these operations at runtime, and they are moving some of these operations to do them during compilation, right? Because doing all these things at runtime when your application starts will cost you startup time and memory consumption. We'll get into that later. So are there any other alternatives for runtime annotation processing or discovery? There are. Like, for example, we have a library called ClassGraph. ClassGraph is a third-party library. It's used by utilities like, for example, OpenRewrite. OpenRewrite is using ClassGraph, and a few others as well. What ClassGraph is doing, to avoid the cost of loading the class into a class loader, what they do, they swallow the bytecode directly, right? They read the bytecode. They have the ability to understand basically the bytecode. So that's why you don't have to load the class. And well, it's a very feature complete. It has the ability, for example, to load insert jar files without having to extract them. And the implementation, considering that it's at runtime, is highly optimized. And then there is, for example, another library in Java called Burning Wave Core, which is using a similar approach. You can use in Burning Wave Core or ClassGraph to find classes at runtime. Now, that's basically at runtime. That's the only two possibilities. You either load the class or parse the bytecode. There's no other way, right? At runtime. So how do we implement? What are the options to implementing the annotations? The first one, which is a built-in capability of the JDK since forever, this has been around like forever, is dynamic proxies. This is a capability of the JDK which allows to implement on the fly at runtime implementations of a given interface, right? So the JDK will literally generate bytecode at runtime and then load this anonymous generated class into the class loader. And it's limited to implementations, sorry, to interfaces. So you cannot use this with a normal class, right? There is a flag, for example, in Spring to make it work with dynamic proxies, like to force it, because it's not by default. But if you do that as soon as you use an annotation in a normal class, it will basically throw an exception and tell you that you need to disable that flag. What else? There is like a library called cglib. Cglib is essentially what Spring is using. It is a mature library, like I don't know, 10, 15 years old, so it's been here like for quite a long time. And it's used to generate proxy implementations for interface or any other regular classes, right? And it can be used also to, they call it dynamically enhance, and I call it mutate, and that's problematic. Because you can tamper with existing classes, you can modify, you can alter them. cglib itself is no longer maintained. However, Spring has its own fork. So basically, Spring is not using the upstream cglib, but their own fork. They maintain it. It works for the use case. And yeah, you don't have to worry about that. cglib and many other alternatives use something called ASM. ASM is the foundation, or up until now has been the foundation library for doing bytecode manipulation. ASM is a very low-level library, so you don't work with Java programming building blocks, but you work with bytecode instruction set building block, right? So you need to understand, for example, which is like a load instruction on the bytecode, etc., and it's a very low-level API. There is something much more modern, which is called ByteBuddy. ByteBuddy is used by Hibernate, Mockito, Jackson, Selenium, Spock, Etherj, and possibly many others, because ByteBuddy it has 3 modes of operation. You can use ByteBuddy with Java API, which is what I use on my demo. You can use it as a Java agent that you attach to your build, or you can use build plugins, and they will basically attach the agent for you. It is very fast, considering that this is happening at runtime. Like, for example, in Jackson, to implement all the serialization and deserialization, Jackson will not only use a ByteBuddy for the code generation, they will also use reflection. And it has a very nice API, it's well documented, and there are many examples. And finally, there is a standard very recently in Java, which is called the class file API. The class file API, which has been released very recently, is a standardization for the use of ASM in the JDK. Because the JDK itself, like I told you before, when you use dynamic proxies, they will generate bytecode at runtime, and they would use ASM for that. However, using ASM inside the JDK is problematic, because how can you make a new release of the language if the ASM version that you're using is not supporting that version yet, right? So they had to do tricks. And also, ASM is known to be an old code base with plenty of legacy baggage. That's a quote from one of the Java architects. So it was a matter of time to basically replace it, right? The API is kind of similar to that of ASM, but you don't have to have any standard, any external dependency for this. OK, so let's make an example. Is dark mode good enough? I think so, no? Yeah? So in this case, let me show a random service class. And we have an annotation called timed. Timed is an annotation with a runtime retention policy, because in this case, I'm going to use ByteBuddy. And the retention policy of the annotations means that if it's a runtime retention policy, if I use reflection to query a method where this annotation is going to be present, I will see it. OK? And for that to happen, it has to be on the bytecode. So the compiler will retain the annotation when generating the bytecode. This annotation is in a method. The functionality is very simple. So you essentially, we want to measure the time that the method execution takes, right? This method in particular does nothing. The only thing that I introduce is basically a random weight so that we get different execution times every time we test it. So far, so good. Yeah. Blink your eyes if everything is going well. OK? How do we implement this with ByteBuddy? It's quite simple. This is a main, like a main class, main method. And then there is a Java API where you can say, OK, I want to subclass this guy here. There are different options, right? You could say, like, for example, I want to subclass all the implementations of this interface or something like that. So ByteBuddy has its own sort of class path scanning to find annotated classes. And I want to intercept, well, I want to generate a new class which will be named like my time service with a suffix, right? Because this class is going to be generated at runtime. And I want to intercept methods annotated with time annotation and then delegate to this implementation here. And the implementation is very simple. So you basically have to implement an intercept method. And this super instance is an instance of the actual method, the actual object that is being invoked, right? So we measure the time at the beginning, delegate the call, and then measure the time at the end, right? It's quite simple. If I run this, and the demo codes are with me, which I hope, we should get something here. Yeah, and if I run it again, it still works, right? If I run this in debug mode, however, I can see that the instance of my time service is not an instance of my class. It's an instance of the proxy. You see that? And this proxy is not here, right? There's no dot class for this. It has been generated at runtime, right? This happens all the time when you use Hibernate, when you use Spring, when you use all those frameworks which use runtime proxies of one sort or another. Your instances of your objects are not instances of your classes at all, right? They're something else. All right, let's move on. So what's wrong with this? First of all, class path scanning is slow. To do class path scanning, we need to do I/O operations on the disk to read the class files. And we need to do I/O operations on the disk to load jar files and to unpack them to find classes inside the jar files, right? So class path scanning is slow. Reflection API is slow. It's quite slow. It's a CPU-bound operation, right? And it is true that with every Java release, every new Java release, reflection is getting faster and faster, but this is still somewhat slow. So what happens is that because reflection is slow, Spring, for example, will have a reflective cache, so that you're not querying over and over again which are the methods of a class, which are the annotations of this method, etc. They cache that in memory, right? But you guess what? You're likely not only using Spring, but also Hibernate or Jackson, right? And they will have their own reflective cache, which is different, right? So memory consumption will skyrocket, and there is no limit, memory consumption and startup time when you do runtime annotation processing is a function on the number of classes and dependencies that you have in your project. The more dependencies you have, the more classes you have, the more time the application will take to start up, and the more memory will consume. But we're not done yet, because we actually have to implement this class. We need to generate bytecode, and this is a costly operation as well. And remember, this happens every single time you start your application. And you may argue, I don't care because I run my server on the cloud once and I forget. And that's not the answer. The reality is that you should be running your application much more frequently, and that is for running tests, right? What happens, on the other hand, is when you're using a framework that is taking so long to start, then we have this mocking ceremony in the test, because it's basically unpractical. It's impossible to write end-to-end tests for everything, right? But that's not because end-to-end tests are bad, but that's because it is expensive to start the application, right? And finally, there is a final consequence, and is all of these runtime operations will make it harder for GraalVM native image to work. GraalVM native image supports reflection and proxy generation, supports all of that. But you basically have to tell GraalVM in advance that you're going to be generating a proxy for an interface, for example, right? Because, or for example, if you are doing dynamic class loading, you need to tell GraalVM in advance so that it puts the class on the image. Otherwise, you will get it's not on the image at runtime, right? GraalVM has an agent that will generate this metadata, but essentially it's an extra effort, and it's the reason why, for example, Spring Native took 3 years to complete, because they had a huge effort to basically collect all the metadata necessary in Spring to make Spring work with a native image. So this is all the options that you have for runtime annotation processing. So let's talk about compile time annotation processing. Let's move to the first stage. So how do we discover annotations during compilation or build? And I will explain this difference later. There is a utility called Yandex. Yandex is a class indexer, and is used by Quarkus. But this is going to be, Quarkus is not working during compilation, it's working during build. The difference is that the build is essentially the whole end-to-end process of Maven, for example, or Gradle, right? And compilation is one of the things that happen during the build, right? Quarkus doesn't work at compile time. They work at build time, right? They do what is called a build time enhancement. And in particular, they will run Yandex during this build process. And Yandex is essentially will parse the bytecode, but not at runtime, but during the build, and will collect all metadata into a persistence index. It's literally one file, and then Quarkus will load this file into memory at the startup, and then they have all the information they need for annotations, right? You don't have to use the reflection API at all. which is a huge benefit, right? The avoid of reflection. Now, to implement the annotation logic, they use another library called Gizmo. Gizmo, which once again is written on top of ASM, can be used to generate new bytecode or actually to mutate existing classes, right? Quarkus has like 2 ways of bytecode generation. One is, like for example, if you're writing a Quarkus extension, you can use what they call bytecode recording. They have an API. This is the sample on the well, the pointer doesn't work. The sample on the right. There is some annotations that they will process during the build and will generate this bytecode for you during the build. If this isn't enough, then you can use the Gizmo API directly, right? That's another option. And finally, let me talk to you about Pluggable Annotation Processing API, which was introduced in December 2006, right? This has been forever. It's a standard in Java. It's called basically annotation processors, right? And this was introduced in Java 6. So I bet we have someone in the audience who wasn't born yet in 2006. That's a possibility. So annotations processors are essentially compiler hooks for Java C. So annotation processing happens during Java C. And this is why I make a distinction about build time versus compile time. This is compile time, right? And well, there is an API, a Java API, to implement an annotation processor, right? There's essentially few methods that you have to implement. It is used by frameworks like Micronaut, for example, and libraries like Lombok or MapStruct. Who is using Lombok here? But keep your hands because I want to remember your faces because I will look after you later. Annotation processing is done in several rounds because during annotation processing, you can generate source file, which has another annotation, right? So Java C will detect that and will launch a new round of annotation processing. During annotation processing, you only have sources available. So basically, the inputs to Java C. There's no application dependencies. There's nothing like that, right? So it's a very limited and very different class path. And you can have, for example, imagine that you want to generate, I don't know. So do you know what's decorate? Yes? Decorate is an annotation processor that you put some annotations in your classes, and they will generate Kubernetes descriptors for your application, right? So during compilation, they will read those annotations, and they will produce a YAML file, right? In order to do that, it's irrelevant if you have a snake YAML on your class path. They need their own dependency on snake YAML to generate this YAML file, right? So that's the idea. Obviously, annotation processing class paths should be kept minimal because otherwise compilation time will be bigger. What can we do with annotation processing? We can, for example, generate source code, which is what MapStruct and Micronaut are doing. We can generate new bytecode, which is the most typical case of Micronaut. We can modify existing classes, which is what our friend Lombok is doing. Or we could do something else, like, for example, I set the sample of decorate. Micronaut, for example, has an annotation processor to generate OpenAPI spec file from your code, right? So that's another example. You don't have to generate something related to Java. You could generate a different file. So the case of Project Lombok. So you didn't see that, but most of the audience is using Lombok. And I tend to say that there are no Lombok users, but there are Lombok addicts. Because Lombok is like cocaine. It's all happy at the beginning. It's very funny, but you no longer will be able to get rid of it. So what's wrong with this happy pepper? What's wrong with it? So let me introduce you into the fantastic world of Java compilation. It's a fantastic process. I recommend you to read about it. So Java compilation is done in 3 stages. We have the parse phase, we have the annotation processing phase, which we talked about, and then the generate phase. So in the first stage is essentially when the compiler will check the syntax of your program, right? It's checking if basically the grammar of your program is correct. So if you have a missing semicolon, this problem will be raised in this phase. We will not go further, right? If everything is correct and the syntax of your code is correct, is legal, then Javac will build something called the AST, Abstract Syntax Tree. This is a tree representation of your code. So an AST contains, for example, a compilation unit. A compilation unit contains, for example, statements. A statement may contain, for example, a conditional operation or a method call, right? You follow me, right? That's the AST. It's a model of your code. And this is the input to annotation processing, which is the second round, right? And this is done in a loop. There may be multiple stages, because if we generate sources that will have to be a further annotation processed, then Javac will claim a new round until there are no pending annotations to be claimed, because that's one of the things that you have to provide in your annotation processor. You have to tell Javac which annotations are you processing, right? Once all the rounds of annotation processing have been done, we enter into the analyze and generate phase. And in this phase, for example, the Javac will do some of the magic tricks, like, for example, custom folding or method inlining. We'll do all these optimizations, and after that, we'll persist the class file, right? The bytecode into a file, right? Now, it happens that Lombok is an annotation processor. So now I ask the question, how the hell is possible for Lombok when you add the add_toString, which is like an innocent annotation, right? It's a very innocent. You add toString, and then magically a toString method appears in your class, even if you didn't define that. And it's not the toString coming from object. It's a different method, right? So how it's possible for Lombok to do that? And the reality is that the annotation processing API doesn't allow you to modify classes, because the AST is a read-only, kind of, right? So you're given this AST during the annotation processing. But they manipulate the AST. The AST of your code is being changed, right? They inject new methods or change existing ones to do their magic, right? So in this case, they will take the AST of your class and they will mutate it. And they will inject a new method declaration AST, so that this toString then appears at runtime, right? And that's not the bad part. The bad part is that to do so, they are using loopholes in the JDK, which are undocumented, and then they are like very dirty tricks to make this happen, right? So they basically hijack the AST during compilation. And they have to do that for every single compiler on the market, because these loopholes are not the same on Eclipse compiler, for example, than, for example, OpenJDK, right, or OpenJ9. Believe me, it's terrible. So there are many functional problems that you will have with Lombok, right? And when you search on the internet Lombok problems, the majority of the problems are related. Like, for example, if you use add data on a JPA class, that's going to be a disaster because you will have extra columns for many things you don't need, right? So don't do that. But I'm here to talk to you about the technical problems that Lombok is introducing. So first of all, it's using loopholes. And these loopholes are going to be closed. They will be closed, sooner or later. Because there is the direction of OpenJDK is to close them all. And if they didn't do that already, it's essentially because all of you will be mad at the OpenJDK team saying like, oh, you made Lombok not working anymore, right? So shame on you, but that's not the reality, right? So they are like closing, like on every release they are closing one or two, but they will be closed. So this is like a cat and mouse race between Lombok and OpenJDK, this essentially is going to limit your ability to upgrade to a new Java version, right? Because when you're using Lombok, you are not able to upgrade to a new Java version on the first day, right? You have to wait for Lombok to support it, right? And this is a problem on every release. Mutating the AST is morally bad, but technically it's also a disaster because, for example, if you run Lombok with Micronaut and Lombok is running as the last annotation processor, Lombok will destroy the bytecode generated by Micronaut. It will basically render unusable. So you have to make sure that Lombok is run first, right? That's something to consider. And also, AST manipulation will break incremental compilation. By the way, incremental compilation is something you are only going to benefit if you're using Gradle. Is there anyone using Gradle here? Yeah? So incremental compilation will only work with Gradle, but not if you're using Lombok, right? Lombok will break not only incremental compilation, but also Gradle has the ability to do incremental annotation processing, right? And by incremental, I mean only recompiling what was changed. And the main question is, I get why Lombok is or was a thing with all Java releases. Like in Java 8, we didn't have like modern building blocks. So the first version of Lombok, by the way, was introduced in 2006, more or less right after the Annotation Processing API. The first version of Lombok has a desktop installer because it had to be installed inside your local Java installation, right? Because it would copy files over there, right? So Java is not like that anymore, believe me. So if there is like a single advice that I dare to offer you today is, in general, please reduce the number of dependencies. And in particular, please remove Lombok as soon as you can. So, but yeah, that's the end of the Lombok rant. So, how do we do that in Micronaut? So, is anyone here who never heard about Micronaut before? Yeah, OK. So 30 seconds about Micronaut. Micronaut is a modern open source Java framework. The team behind Micronaut is also the team who created Grails. You remember Grails? Grails was a framework based on Groovy and Spring and Hibernate and a few other things. We spent 12 years doing Grails, and we learned quite a few lessons about what to do and what to not do. So we wanted to start from scratch, thinking on the type of applications that are created today, right? We are no longer creating Word files or ER files, right? We're no longer doing monolithic applications, but instead, I don't know, serverless, microservice, etc., right? It's a general purpose framework. You can use it for anything you want. People typically use it for doing REST API microservices, but you can have serverless function and deploy it on AWS Lambda or OCA function. You can have a command line application. You can have a headless Kafka consumer producer with no HTTP server whatsoever, so you name it. And the third idea, it is highly optimized. For us, performance is an obsession, and performance is not only like peak performance, which is there are benchmarks out there that you can check to see the performance of the framework. I can tell you that it's competitive, but the two particular metrics that I'm talking about here is startup time and memory consumption, because we believe that startup time and memory consumption will dramatically change your developer experience to be better. The way Micronaut works is essentially a set of annotation processors that will compute all the framework infrastructure at compile time, processing source code. And we generate bytecode for most of the cases, but there are some cases where we're going to be generating source code. The problem of generating source code during annotation processing is that that requires a new round of annotation processing, right? Yeah. So basically, at runtime, Micronaut has no reflection, not at all. There's no proxy generation. There's no dynamic class loading. We don't scan your class path ever. So you can think about Micronaut like a set of compiler plugins, a set of multi-language compiler plugins, because we know not only support Java, but also Kotlin and Groovy. For example, in Groovy, this is implemented using AST transformations. Groovy doesn't have annotation processing, has something else called AST transformations, but Java and Kotlin do. And Micronaut is batteries included. So we are offering you built-in elements, which I'm highlighting in red, so that you don't need the things in blue. We have bin introspections, which are a replacement for the JDK introspector, which is based on reflection. We have a built-in bin validation API, a replacement for Hibernate validator, which is much faster and will consume less memory. We have bin mappers as a built-in alternative to map abstract. We have micro-serialization, a drop-in replacement for Jackson, especially for Jackson data vine. Micronaut data DevBcn, which is having compile time checks, and it's an alternative to Hibernate, much faster. And all of this is going to be compatible with GraalVM native image since day one. So we strive to help you reduce the number of dependencies that you need in your applications. So let's see this timed example now with Micronaut. In this case, I have the annotation here. It has a source retention policy. If I were to use the reflection API to query the annotation at runtime, it will not be present. So this is also going to save a few bytes, because it's not going to be in the bytecode, in the class, right? It's not much, but everything counts. So source retention policy, because we don't need it at runtime. And this is like a Micronaut AOP annotation to basically trigger the processing of these elements during compilation, right? And then we have the interceptor. In this case, the interceptor is method interceptor. And the implementation is very similar to the other one. The context object contains basically the method invocation that is being intercepted. So we measure the time at the beginning, delegate the call, and then measure the time at the end. And this is a singleton bin. So that's all you have to do. Then the main class, what I'm doing on the main class, I'm running the Micronaut application. I'm getting the bin from getting my service from the application context, invoking the methods, and that's it. If I run this, it works as expected. And if I run this in debug mode, this service is also a proxy, right? This is a proxy, but this proxy is here, right? It's all here. See my point? We have a new module called Micronaut Source Gen, which is a language-neutral source generation. We are introducing it with a few annotations to reduce your drag dependency on Lombok, right? So this will help you to make the transition, right? Not only on Lombok, but also on map extract. So for example, we're shipping builder and toString and a few others, right? And with the promise that we will never mutate your classes, right? That's a red line for us. So why is startup time and memory consumption important, right? I told you this is going to change your developer experience. So I have like a long-running application. I run it on the cloud and I forget about it. Why this is important? And there are two shapes of this answer. One is developer productivity, because you can run end-to-end tests within milliseconds, right? When you work with Micronaut, you forget about mocking. You don't have to use mock MVC, mock that. No, you just have one test that will spin an instance of your application. You grab your bin from the application context and you make a method call to it. And that's it. You forget about anything else. And that runs within milliseconds, I promise. It's ridiculously fast, right? Also, if you want to use development mode, which is running your application on the terminal, right? For example, in development mode, Micronaut doesn't have hot reloading, because hot reloading is a technique that will basically replace classes into existing class loader, and that's a kind of worms. There are many things that can fail with that. So the approach we took is basically when you change a class in your project, we kill the process and restart it, and you don't even notice, right? That's one thing. The other thing is, if you are deploying into a cloud-native runtime, like for example, Kubernetes or anything like that, if you have a service that can come up very quickly, then you can get almost scaled to zero, right? You don't have to have like too many replicas. Well, you can have as many replicas as you want of your application, but when the load is reducing, you can scale down, right? Because you have the confidence that if there are more users coming again, you can spin new instances very quickly, right? And if you want to squeeze it even more, you can use GraalVM native image, and that will give you like ridiculously fast startup time. So we're talking about Micronaut Hello World in JIT mode is going to be 200 milliseconds, more or less. But in GraalVM is going to be 8 milliseconds, right? So that's almost instant. So with GraalVM native image, you can scale almost to zero. The other example is serverless. In serverless, the more time your function takes, the more money you pay. And using Micronaut and GraalVM will literally save money. And that's exactly the use case of Disney+. Disney+ has one of the microservices, is like a messaging service with very high traffic. They deploy many things on AWS Lambda, and they realize that that going with Micronaut and GraalVM will help them to save a ton of money, which is great. So I have this QR code with you have my social media details, and also there's a couple of questions. So I will be eternally grateful if you can provide feedback. So feel free to take a photo. Did you learn something new? Yes? Do you have fun? Thank you very much. Muchas gracias, and thank you.